right, these are the notes for 7.5 part 2. And it is called Rationalizing with Two or More Terms. So we're going to do all rationalizing today. But instead of just rationalizing like the denominator where it only has one term, like the cube root of 12, we're going to be rationalizing where there's more than one term in the denominator. What am I holding here? Alright, so one thing I want you guys to remember from yesterday, is that if we do the square root of a plus the square root of b times the square root of a minus the square root of b, so we did this problem and a couple like it yesterday, and remember that looks like that's a factored form of a difference of squares. So if we unfactor that, if we multiply it out, and we're kind of thinking about the shortcut here, it's going to be a squared, so if like this is our a value, the square root of a is our a value. What's the square root of a squared? A. This just turns into a minus, because it's a difference of squares. This is our b. It's b squared. So what's the square of b? The square root of b squared? B. So remember, this turns into just a minus b. That happened yesterday. You can look at your notes yesterday. We did this problem and it happened yesterday. Because this square root of a times the square root of a is a. And then we do minus square root of ab plus square root of ab. Those cancel out. And then minus square root of b times the square root of b is just b. So that gets rid of all of our square roots. So we're going to use that to our advantage to get rid of square roots in denominators. So we're going to be multiplying by stuff to make that happen. So here's an example. And it is going to say, write an equivalent expression with a rationalized denominator. So honestly, the instruction could have just said rationalize a denominator. Right? An equivalent expression with a rationalized denominator. So we're going to start off with a kind of easy one, although they honestly don't get a whole lot harder than this one. So here's our example. 4 over 7 plus square root 3. 4 over 7 plus root 3. So right now, this is bad because there's a square root in the denominator, and we do not like that. We want to rationalize it. So what you want to do, anytime you have something that you need to rationalize, and there's more than one term, so there's two terms in here, we need to multiply by this conjugate. A conjugate just means that you change this sign. So we're going to multiply 7 plus root 3 by 7 minus root 3. So what we're doing is multiplying by the conjugate. Conjugate. There's a J and a G in that word. So that's what you want to do. Anytime you see a square root in your denominator and there's more than one term, you multiply by the conjugate. You keep this the same and you keep this the same. You just change this sign to the opposite. That's it. Yeah? Oh, no. It will never be a multiply in here. If it were a multiply, there wouldn't be two terms. It would just be one term. 7 root 3 would just be one term. So let's go ahead and multiply this. All right. On the top, I have to distribute, right? I'm doing 4 times 7 minus root 3. So we're going to do 4 times 7, which is 28. And then 4 times negative root 3. What's that? What should I write? Minus 4 root 3. I just did 4 times negative root 3, so it's negative 4 root 3. Okay, there's the top. We're done with the top. Now the bottom is the bigger part. So on the bottom, we're going to want to jump to our shortcut. We do not want to multiply this out and write it all out every single time. So all you want to do is, this is a difference of squares, right? This times this. We're just going to unfactor it. So all you do is take your a value and square it. So what's 7 squared? 49. We got that because that's a. Why does that keep happening? A squared. And then you always put a minus. Because it's a difference of squares. And then you put whatever your b is. In this case, our b is the square root of 3. We're going to put b squared. So what's square root of 3 squared? 3. Isn't that great? It got rid of all the square roots in the denominator. Well, no, we're not done, because what's 49 minus 3? 46. So we can write that. 28 minus 4 root 3. And then we're still not done, just so you know. Over 46. So we just subtracted on the bottom. There's one more thing we can do. Liv? Do you guys know what it is? Well, we can't subtract these because one of them is a root 3 and one of them doesn't. They're not like terms. Cameron? We can't just combine those. It won't be fair. McGill? We can't just divide the 28 by 46. It wouldn't be fair. Elise? We can divide this, this, and this all by 2, right? It's kind of like heart method. Remember heart method last year? So like we can't just divide this guy by this guy. We have to simplify every single term we see there. So we can divide this by 2, the 4 by 2, and the 46 by 2. We can divide all 3 of those by 2. So if you can divide everything by the same number, you can do it. Now, if this 4 was like a 3 or something, this wouldn't work, because you have to be able to divide that guy, and that guy all by the same number. So let's go ahead and do that. 28 cut in half is 14. 4 cut in half is 2 root 3. So we basically cut 4 root 3 in half. That's 2 root 3. And then on bottom, 46 cut in half is 23. And then I think we're done. Well, we don't want to put anything on the outside because we're not simplifying any square roots. We're just simplifying. It would be kind of like if we had had. It would be kind of like if we had had, like, let me just make something up here. 2x minus 10 over 2. It would be kind of like that. We could divide this, this, and this by 2, and it would just be x minus 5. Because we can do that, right? All right, next one. So we're going to do the same thing here. We're just going to try to rationalize the denominator. So this one's going to be a little tougher. We're going to do 4 plus root 2 over root 5 minus root 2. And we are rationalizing the denominator here. Raise your hand if you think you can tell me what to multiply this by on top and bottom. Esther? There you go, square root 5 plus square root 2. That's the conjugate. So we just multiply by whatever's on bottom, but we change the sign. That's it. This one's going to be more annoying to multiply, though, right? Because look at the top. It's going to be really annoying. That's fine, though. We can do it. So on top, we're gonna have to like do the whole FOIL thing here. Do you guys like to think of FOIL, or do you just think of like I'm multiplying this guy to both and this guy to both? You just do that. Okay. All right. So we're multiplying 4 times root 5. That's 4 root 5, right? You guys correct me if I do anything wrong, because I'm not looking at my notes. And then we got to multiply 4 times root 2. So that's positive 4 root 2. So I'm like halfway done with FOIL on the top. And then we've got to do the root 2 times both of them. So root 2 times root 5, what's that? Root 10, positive root 10. And then I've got to do, what's root 2 times root 2? 2. But let me ask you guys really quick. Is the cube root of 2 times the cube root of 2, is that just 2? No. I'd have to have 3 2's to make that right? Okay, just making sure we got that. So we're done with the top. Now let's do the bottom, and let's try to do the shortcut. Okay, let's do the shortcut. So remember, we've got A and B here. And we're just going to put A squared minus B squared. So what's my A, which is the square root of 5? What is my A squared? Be confident. Say it loud. 5, right? That's my A squared. Then what sign do I always put right here in difference of squares? Minus, because it's a difference of squares. That wasn't even funny. And then we've got the B squared. What's my B squared? 2. Good. Isn't that great? Yeah, the bottom's just 3, and those square roots are gone. I think these are pretty, I like these problems, yeah? We need to see if we can simplify the top, yeah. So let's rewrite that with the 3 on bottom. So I've got 4 root 5 plus 4 root 2 plus root 10 plus 2 all over 3. Like with the notes completely. After this one, we've got 1, 2, 3 more examples. Yeah, they really are short. Now let's check really quick to see if we can simplify anything here. Can we add any of these things together right now as they are? No, they're all different. Though none of them are friends. Let's see. Can we break 5 up? No. 2? 3? We're done then. And we can't divide. If we could divide 4, 4, 1, 2, and 3 all by the same number, we could simplify it more, but we can't. We can divide them all by 1 forever, right? Over and over and over. Oh, I don't know why I wrote that. Oh, I was thinking of 3. No. I was thinking of 3 because I was writing the bottom. That's not a mathematical error. No. Huh? Oh. No, like your guys' pictures are up there from last year. Were any of you on it from last year? Jub's picture is from last year, I think. And everyone else it has Miss Newberry now, who I had last year on there. Yeah, everyone else has Miss Newberry. Everyone else on there has Miss Newberry. Yeah. I'll have to spread it out on the wall around it. Maybe. Maybe. Alright. So in this one, we're going to rationalize the numerator. It's a little different. What are you doing, Lauren? Write this down. This time, we're not rationalizing the denominator, we're rationalizing the numerator. So it's okay if there are square roots in our denominator. No. No. Because pluses mess everything up when it comes to canceling out. No, we couldn't still. You'd have to be able to divide this, 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 and this all by root 2. I know it is. All right, let's do this one. Raise your hand if you think you can tell me what I need to multiply by on top and bottom here. Elise? She is correct. Because we're rationalizing the numerator, so we need to multiply the numerator by its conjugate. You just keep them the same, but you put a minus. Do you guys want to try multiplying that out on your own? Okay, let's do it then. Oh, Jake really wants to be on here. Make your own YouTube channel. We will. I'll promote it on my really popular channel. I'll post little. Don't people post like links to things on it? I could do that. Yeah, I could do that. Yeah, I could do that. All right, so let's multiply on the top. Do we need to multiply it all out, or can we do a shortcut? Shortcut, right? This is a difference of squares. So on top, I can do my a squared minus b squared, because this is a plus b, a minus b. So on top, I'm going to write a squared minus b squared. What's my a squared? Here's a.
4.
What's my a squared? 16. And I always put a minus. What's my b? Here's b. What's my b squared?
2.
Just 2. We can simplify that later, because we know 16 minus 2. On the bottom, we can't use this shortcut, right? We have to actually multiply this all out. So we're going to have to multiply first root 5 times 4, that's 4 root 5. Outer root 5 times negative root 2, that's negative root 10. Inner negative root 2 times 4, that's negative 4 root 2. And then last, negative times negative is positive. Root 2 times root 2 is just 2. So positive 2. You know, some of these end up being long. We can definitely simplify the top of this, right? What's really on top? Just 14, right? 16 minus 2 is 14. On bottom, can we simplify anything? I don't think so. They're all different roots. The 2 is just a number on its own. And I don't think we're even going to be able to divide by anything, right? Why can't we divide by everything by 2? Which one thing is messing it all up? No, the 5 doesn't matter. That's in a square root. I don't care about that. The negative square root of 10 is messing everything up, right? Because there's a 1 out there, and we can't divide that by 2. That's the guy messing everything up, but we can't divide by 2. Do you guys see that? It's not that we don't care about what's in the square root. We couldn't divide that anyway. That's our answer. That's it. I know these answers look yucky, which is like, I know when you're taking a test that's like crummy because you feel like, oh, this could not be right, but they are. All right, ready? We have 2 more examples, and one of them is so short, I don't even know why we're doing it. All right, so we're going to talk about terms with different indices, which basically means we're talking about different types of roots. We only have 2 more. We only have 2 more examples. For example, a square root and a cube root. Indices is the plural of index. So, like, the way you'd think you would say it, if it were like a normal word, would be terms with different indexes. Like, I don't know why we wouldn't just use indexes for the plural of index, but whatever, I didn't make up our language. No. Wait, what do you think is a 1? Oh, that's a comma. Yeah, sorry. that did look like a 1, sorry. That's a comma. So it's going to kind of mess everything up when we have different types of roots in here. So here's our example. We're going to divide and then simplify if we can. I'm just going to write simplify. It should say simplify if possible, but just always assume you should simplify it if you can. And here's our problem. It actually won't be too bad when we do it. So what's nice about this problem is that there's an x plus y in here and an x plus y in here. They're all different. It's different types of roots. This is a fourth root. This is a square root. It's x plus y cubed in here, and it's just one x plus y in here. But the nice thing is that they both have an x plus y. If they didn't both have an x plus y, we probably couldn't really do anything with this problem. But they do both have that. So what we're going to do first is we're going to write these with no roots, just powers. So on the top, we have x plus y, and we're going to put a fraction exponent up there. What's the numerator on my exponent going to be? 3 or 4? Which one's the numerator on top? 3's on top, 4's on bottom. The one with the one that's the index is always the denominator. And then on bottom, I've got the square root of x plus y. What fraction is that for an exponent? A half. A square root is the same as taking something to the power of 1/2. So now, since we have the same base here, raise your hand if you can tell me what I could do with those exponents. Yeah? No. Subtract. If we're dividing, we subtract the exponents. But I said, what do I do with the exponents? You subtract them. We're not dividing 3/4 by 1/2, we're subtracting 3/4 minus 1/2. So we're going to subtract these exponents. You should not be scared of that. You should just go to the side of your paper and write out 3/4 minus 1/2. And you might already just know this in your head. But to subtract fractions, what do you have to have the same? The denominator. So if I change this one to a 4, what do I have to change the top to? A 2. I multiplied both of those numbers by 2, right? This is like 5th grade right here. So then we leave the denominator of 4. We've got 3/4 minus 2/4. That's 1/4. So I'm going to go down here. This is really just x plus y to the power of 1/4. And then let's just assume that since they were giving us the problem with roots, they want us to write the answer with a root and not an exponent. How can I write this as a root? Is it a square root? It's a fourth root. Should there be any power outside the x plus y? No, because it's just a 1 up here. So that's our answer. See, that wasn't even too bad. And then I have one more, and it's so easy that I don't even know why we're doing it, but we'll do it really fast. I don't know. I guess there's examples like it that I'm guessing there's problems that I'm giving you like this. So we're just going to multiply. It'll take us like 90 seconds. And simplify. And we're going to multiply the square root of x cubed times the cube root of x. I think we've done problems like this, but we'll just do it for practice. So right now, we can't really multiply these and put them into one root because they're different kinds of roots. So anytime that happens, try writing them with exponents instead. So how could we write this guy as an exponent? What would his exponent be? 3/2, right? 3 on top, it's a square root, so 2 on bottom, times, what would the fraction exponent of this guy be? 1/3. Now, since I've got the same base and I'm multiplying, what should I do with the exponents? Add them. So I've got 3/2. We can do this. We can add fractions plus 1/3. What should I make the denominator on both of those? A 6. So I've got to multiply the first one by 3 and the second one by 2. So we've got 11 sixths, right? No, 9 plus 2 is 11. So we've got x to the 11 sixths. And then what I would do is let's write this as a mixed number and then we'll put it back into the root. So what is this as a mixed number? 1 and 5/6. Because 6 fits into 11 once, and then there's remainder 5, and you always keep the denominator the same, yeah? Well, it's just going to help us, because since they gave it to us in roots, we're going to assume we should put our answer in a root, unless it said not to. So, we've got one whole x that gets to come out, and then we've got this guy's the root. X to the 5, and it's the 6th root. So that's our answer. So the 5 went right there, the 6 went right there. Okay, and that is the end of our notes. So you should do page 467, 65 through 95. Ah, you have so much time in class. This is great. This is a nice Friday.